Alright, so I've worked a little bit with inverse functions before, and it makes no difference whether we're working with exponentials or log functions, same principles apply. First things first, the graphs themselves need to be, or the functions need to be one-to-one. So if we consider what the exponential function looks like, which is that one, or consider what the log function looks like, both of those graphs are one-to-one, so that's no issue. The other things that we need to recall is that to find my inverse function, we exchange, don't we? We swap y equals a to x so that we end up with instead x equals a to the y. So we end up with that relationship. And once we have that, we use this relationship here, that log base transformation, to get it from log form into index form, or from index form into log form. Okay? So let's have a look. Find the inverse of y equals 3 times 2 to the x plus 1, state the domain and range of the inverse function. So I guess the first things I like to do, if I'm going to find an inverse, if we have a quick sketch of the original function, 2 to the x times 3 just makes it a bit fatter, plus 1. So all that really matters is, my graph looks a little bit like that, and that horizontal asymptote is up here at y equal to 1 instead. So you can see the domain is R, and the range is equal to 1 to infinity. So we'll get that because we're going to use it for our inverse function. So let's find our inverse. So to find our inverse, let's swap x and y. So x is equal to 3 times 2 to the y plus 1, and now we solve for y. So if I make, that means subtract 1 and divide by 3, I get that equal to 2 to the y. So even if we tidy that up a fraction, 1/3 of x minus 1 is equal to 2 to the y. So now if I get my log base 2 of 1/3 of x minus 1 is equal to y. And that's okay, we can leave it in that form. Now to state the domain and range of this particular function, so actually we don't leave it as y, do we? So we're going to write that instead as, we can just write it as y inverse, so let's rub that y out. So we're going to say that y inverse is equal to that. So the domain of y inverse is equal to the range of y, which was, what did we say the range was? From 0 to infinity. No, it wasn't from 0, it was from 1. Geez, don't know, I'm sure I said 1. So the range of this graph is from 1 upwards, which means the domain is from 1 upwards, which makes sense. And the range of y inverse is equal to the domain of y, which is just r plus. Oh, sorry, it's just r. I'm all over the place. I'm too busy watching the footy. Sorry, boys. So if we were to sketch the graph of our log graph, even if I do it on the same axes, I've got it. There's my vertical asymptote at x equal to 1. That y-intercept there of the function becomes the x-intercept of my inverse function. And so at x equal to 0, 2 to 0 is 1. That's at the point 4. So my graph will look like a bit like that for the inverse function. Okay. Now if you remember from our inverse functions, our inverse and the function itself are reflections about the line y equals x. So they should be mirror images about that line, which looks kind of like right. Okay. We can, on the CAS calculator, if we want to use that, we can type in. So you can see there when we add the calculate a shot of it all. The solve feature, just transpose x and y and solve it for y. Now don't worry too much about the different format. We can see that the key features are the same. There's my x minus 1 on 3. And we'll talk about what that ln is probably next year. But all we really need to be aware of at the moment is they've just changed it and used a slightly different base. Okay? Yeah, so we can do the same thing for example 11, calculate the inverse. So let's just swap it. X equals 2 log base 10 of y minus 1 plus 1. So x, subtract the 1 across, divide by 2, equals log base 10 of y minus 1. So that implies then that 10 to the x minus 1 on 2 is equal to y minus 1. So y is equal to 10, I'll put a half out the front, of x minus 1 plus 1. So therefore it's an inverse function, so f inverse of x is equal to 10 to the half x minus 1 plus 1. Domain and range, we've considered the domain and range of the original graph. That's a log graph shifted across 1 unit. So there's my asymptote now at x equal to 1. The x-intercept was there, but now it's been moved up 1 unit, so it's there. So the graph might look a little bit like that. So my inverse function, instead of the x-intercept being at x equal to 1, it's now at the point y equals 1, which makes sense. There's my exponential graph moved up 1 unit. The whole thing's been shifted to the right 1 unit as well. So our graph might look a little bit like that, which again, we consider that line y equals x, they're an image of each other about that line. State the domain and range. So domain and range, we better do that. So the domain of f inverse is the range of f. The range of f of that blue function clearly is R. The range of f inverse is equal to the domain of f, and the domain of f is going to be from 1 to infinity, which corresponds to the range of that yellow function, so that's okay. State domain and range of the inverse function with and without using technology. So obviously we can use the same rule here just to rearrange it. Okay, so I'll leave that with you guys.